Hi. Oop. Welcome back. So we're at the end of Unit 8, getting there. And this is it, right? And there is 2 topics left called properties of buffers and buffer capacity. Half of this we already know. So let's just dive on in, shall we? Oh, I'm sorry I sniff all the time. It's because I'm leaning over like this, I think. It used to not have this problem. But I'm constantly leaning over. I think it's just constantly running. I apologize for everything. Okay, once again, this is properties of buffers. I believe at this point, this should be something you know. And buffer capacity. Oh yeah, you guys noticed I changed my background. I'm sitting here always going, oh, I want to change the background. And finally I figured out how. Okay, properties of buffers and buffer capacity. Basically, what does a buffer contain? It contains a weak acid and the conjugate base, or a weak base and the, let's go like this, weak base and the conjugate acid. Oh, that would be a B. Okay. And buffer solutions resist a change in pH upon addition of an acid or a base, and you need to understand how. Well, if I add an acid to this, I mean, we've already done this, then what's going to happen? The conjugate base will absorb that acid, and we will see that we do not have an increase. We have a very small decrease in our pH because the hydrogen ions that are added to the solution are picked up by the conjugate base to form the weak acid. And at the same time, if we were to add a base to this solution, which is a buffer solution, we see that it would be absorbed by the presence of that acid. So the fact that we have both present means that whether we add an acid or a base, both will be absorbed and we will have a minimal change in the pH. All right? Because they won't be added to the solution, they'll be absorbed by the solution in this equilibrium process. The same would occur over here, right? If you add the acid, right? Well, we would see a reaction. The conjugate base would absorb that hydrogen ion, forming the weak base would now form the conjugate acid. And if we were to add the hydroxide ion, right, we would see the hydroxide ion be taken up, actually would try to, there would be a tug of war between that hydrogen. So once again, the addition of the hydroxide, it does not go into the solution, it is absorbed by the conjugate acid. The addition of the hydrogen ion does not go into the solution, it is absorbed by the weak base. And what we see is a buffer solution. Whether we add the acid or the base, the pH only changes minimally. Now, this can only occur for an extended period of time. And that's what we mean by buffer capacity, meaning this system is not an endless buffer, right? It's only got a certain capacity to buffer. Eventually, right, the buffering components, which you should realize are these two guys here and these two guys here, eventually a buffering component will run out. right, a buffering component will run out, and the system will no longer be a buffer. And I could say it will no longer buffer in that direction. It all depends on how far you've pushed it, right? So what will affect the capacity? What is going to create a buffer with a greater capacity? A buffer that can buffer for longer periods of time upon addition of more and more acid and or base. Well, it would have to do with its concentration, right? So the greater the concentration of the both the weak acid and the conjugate base, or vice versa. And remember, ideal is a 1-to-1 concentration. Okay, that's going to give you, your extensions on both sides, and then the greater those concentrations are, the longer those extensions are. So the greater the concentration of weak acid and conjugate base, vice versa, the greater the buffering capacity. And maybe you understand, hopefully you understand, that means there are more molecules to accept the H or the OH, right? All right. Voila. All right, stop and stop.